In this lesson, we'll see some of the data obfuscation techniques. Starting with masking. So masking alters sensitive information while retaining its original structure to prevent a disclosure. The example shows a masking of a credit card numbers. You often see this technique used in online stores where the only last 4 digits of your credit card number are seen so that you know which credit card you are about to use when buying something. And masking can be further categorized as a static masking, so data is masked permanently within the database itself and users never see the real values, and dynamic masking where the data is masked on the fly based on the user's permissions, so certain users can see the real data. Then we have anonymization, and it removes or replaces user identifiable information from the data so that it cannot be linked back to a user. And in the example, the customer ID column, which contains sensitive information, is dropped. And one subcategory of anonymization is generalization, which is about replacing specific values with a more general category. For example, instead of showing exact ages, you might show age ranges, for example, from 25 to 30 instead of 27. Then we have pseudonymization, and it replaces user identifiable information with some ID, and the data can be linked back to a user if some additional information is provided. And the difference between pseudonymization and anonymization is that the first one gives you a way to reconstruct the relationship between the data, whereas with anonymization we cannot do it. And there are two methods of pseudonymization, hashing and encryption, and the difference between them is that hashing is a one-way process. You cannot convert the hashed value to an unhashed form, whereas the encrypted value can be decrypted if we have an encryption key. In the example on the slide, the customer ID is replaced with the hash of the original value. Another technique is aggregation, and it combines or summarizes multiple rows of data into a single result or value. And in the example, customer ID and order ID was grouped by product ID and aggregated into the purchase count column. So all the customers who bought a specific product were aggregated into a single group, and their IDs are not present in the result dataset. And here, over aggregating data may result in a loss of data quality, so it's important to find a balance between protecting your data and making sure it's useful. And the last technique that we'll cover, which is less common, is shuffling. So it anonymizes or obfuscates sensitive data by randomly reordering the values within a dataset while preserving some relationships. In the example, customer IDs were shuffled, but we could also shuffle customers' last names or their addresses so that tracking back the address or the name of a customer who made a certain order was not possible. Or we could shuffle addresses within the same city to retain a regional analysis while protecting personal information.